Hey there, let's start this exercise by first connecting up our 7-segment display to the Arduino. First thing we want to do is get out a piece of paper and a pencil and actually map out everything on the display because it's not exactly obvious. So let's just do the segments first. So we have A, B, C, D, E, F, and G. Now, our next step is to work out which pins to the display these are. So let's go 7, 6, 4, 2, 1, 9, and 10. Right, we're not worrying about the decimal place. So our next step is to draw the pinouts of this chip and to draw which segments are attached to which pin on it. So first up, by starting to draw a box, then we start at pin 1, pin 2, pin 3, 4, 5. This is a 10-pin chip. Pin 1 is E, 2 is D, 3 is the common cathode, which will be going through a resistor to ground. 4 will be C, and 5 we don't use because it's connected to the decimal place, which we're not using in this exercise. Then just put our pin numbers on it. And we do the top ones. And notice that the pin numbers go around in an anti-clockwise direction. That's the same for all integrated circuits. Okay, so they go around, they start at pin 1 and then they just go around in an anti-clockwise direction. So 6 will be B, 7 will be A, 8 again is the common cathode, which we don't need to hook up because we've already hooked it up on 3. 9 will be F, and 10 will be G. Right, that's basically it for our paperwork. Now we need to either go to a physical circuit and work out what we're going to do with a layout, or we'll do it in the simulator, and I'm going to do it in the simulator. Okay, so here we have our Arduino, a breadboard, and the 7-segment display. And you'll see that at the moment, the 7-segment display by default has a common anode. We want a common cathode. So that's like a IC FND 500. And if we go along on Tinkercad, we can see the terminals. E, D, common, C, that's the decimal point, B, A, common, F, G, right? And the way we place this is like this on the board. Okay, so now we can put a wire into any of these sockets here on this column, and it will be connected to the E segment. So start off, we'll just hook up the ground. So I'm going to get a resistor. I've got to change its value to 330 ohms. All right. Now, before I do this, I've got to hook up ground to the board. I'm going to use a green wire, and I'm actually going to, even though it's not super necessary for this particular design, but it's always a good idea, I'm going to hook it up to this rail. So everything on this row is now ground. So all I have to do is drag my resistor, and one end of it's got to be in, oops, I just dropped it. One end of it's got to be in the ground, and then I'm just going the other one up to the common terminal of the IC. So that common terminal is now going through the resistor to ground. Now I'm going to start routing my cables. I'm going to start with output 13 on the Arduino, and I'm just going to work my way down. I'll show you how it's going to look. I'm pretty much picking these to get the best layout. So I can go straight up here. I'm going to change its color because ground is for green. And basically I'm just going to keep going down. So next one, D12, go straight to there. 11 is going to go. I didn't actually put it on the board there. It didn't actually grab. There we go. You've got to be really careful about the wires not going into the actual terminals. Now, if we look at our actual 7-segment display that we've done, just forget about that. You'll see that we don't use pin 5 on the chip. And I think the best way to continue this is to just start going around the chip. Okay, now we can go all the way around the board like this. And then straighten everything up. And I'm going to just continue doing this, and then I'll just show you the final result. Okay, now I'm going to write the Arduino pins on this. So I'm going to do it in a different color. Right, so we start off with 13, 12, 11, 10, 9, 8, 7. So now we go back to our pencil and paper and we just map out our patterns that we want. So for the digit 0, we want all of the outsides to be lit. Okay, so I want these segments. I want A to be lit, so I want a 1, B to be lit, C to be lit, D, E, F. Right? And all the rest are going to be not lit, so they're going to be zeros. So if we want 1, I want B and C to be lit. So again, all zeros. Then for 2, I want A, B, I want G, I want E, and I want D, and zeros. And we just continue on with that. So here's my completed table. And our next step is to basically translate this into software now. Okay, so now I have written a very simple program to display the digits from 0 to 9 and then sort of repeat. The code that I've written is very, very simplex. There are plenty of different ways to do this. This is probably the most basic way that I could think of. Okay, so first up, we actually define the pin numbers for the segments of the display. So I'm using the define rather than integers or consts. I find that in the Arduino compiler, you end up using less RAM if you do this. So anyway, basically, the way a define works is it replaces this bit of text that I've highlighted, the seg A, with whatever the second bit of text is, which in this case is 9. So basically, I've just gone through and I've gone through our little drawing, and for each segment, I've written what the actual pin number on the Arduino is. Okay, We don't care at this point what the pin numbers on the actual chip are, because we're now in software and we're just looking at the pins on the Arduino. I've also got a count delay. That's the time delay between the digits. And now I set up all of my outputs in the setup section. And you notice that if we wanted to change this pin arrangement, or we needed to use a whole different section of pins or something like that in our code, we wouldn't need to be changing numbers everywhere. We would just change these numbers at the beginning. That's one of the reasons why you actually do this. It avoids what we call magic numbers or direct defines inside our code. Now, the way that I've done this, and I'm not certain if it's the absolute best way, but I've written a function, right? And a function in C, that void says that it's not going to return anything. So you can't say A equals set segments, right? If I put an int there, then we would have to return a value. And that would be typically if we're doing a calculation or something like that, we would return a value. In this case, we're not returning anything. So we're just going to call it using the word set segments. There's going to be nothing equals it. So we have void there. Then I'm using Booleans for all of these. So these are going to be the values that I'm going to put in the segment. So a Boolean is just a binary. It's my understanding that in the Arduino, this is actually turns out just to be an integer, so it doesn't really save any memory. Bool is not a standard C type, okay? But it makes a lot of sense in small processors like the Arduino. So anyway, we have all of the values that we want to set in the segments, and then literally we just write the actual value to the segment that we've already set. So that's that pin. Then, after we set the segments, we might as well do the delay here, because this is to write a digit, so we might as well put the delay there. And then literally in our loop, all we have to do, display 0, we set those segments. And that's according to our table that we drew on paper. So everything's 1 except for the G segment. And so on and so on and so on. And let's just get rid of our code. We'll get rid of our drawing. So we'll start it up. We'll start our simulation. Okay, and if we look at it, there seems to be a problem with this when we have the digit 8. Okay, now it's not actually a problem with the segment because we're seeing that segment lighting up on other digits. Let's just stop the simulation. We'll do a couple of things. First up, we'll make sure that that is the case. I'm going to slow the counter down because it'll make it easier to debug it. And you notice I only have to ever change something up the top here rather than in the whole program. And we'll just run it again and we'll just make absolutely certain that this is the case. Yeah, it's not lighting up, okay, just on that one. So what this probably is due to the fact that we've only got one of these resistors. So we haven't hooked up anything to the other common cathode. So what I'm going to do is I'm going to bring this down, again, make it 330 ohms. And I'm going to hook pin 8 to ground. And this is where having ground on the other side of the board is very handy. All I have to do is go up there. Right? So now pin 8 is hooked up to ground via a 330 ohm resistor. We'll start our simulation again. and it worked. And that's basically the whole process from start to finish of hooking up a reasonably complicated device to the Arduino, reasonably complicated digital device. I hope that this video has been of some help to some people.